All right. So coming back to what we discussed yesterday, we discussed about importing data using Scoop, right? So we talked about how you could import data from various sources, various structured as in databases into Hadoop. Although it's not a big deal, you can write your MapReduce program to do the same thing, but it eases a lot of problems. So you can quickly import data from MySQL. Okay. All right. So let me start with today's discussion. So today we are going to discuss Flume, Uzi, and Mahat, and then we will discuss Spark. All right. So in case of Flume, the topic which we discussed yesterday called Scoop was helping us pull the data from databases on demand. As in, whenever we want to import, we can import from a database. But sometimes you want to pull the data from non databases, say a local file system, and you want to pull the data continuously. Okay, continuously as in it's running all the time, there is no end to it. Okay, and these continuously running programs are very interesting in itself. So and when we discuss about stream processing, these are the kind of tools basically do the work of stream processing as well. Okay, so keeping the stream processing aside, let's talk about Flume. So Flume basically pulls data from various kinds of sources into HDFS and other things. Okay, and how do we do that? How does Flume actually work? So essentially, Flume agent, we on every machine we install a Flume agent. Say, let's say you are having 30 servers. On every 30 machine, there is a web server running. On all of these 30 machines, there is a web server running, and this web server is continuously serving requests of the user. And whenever a request is received or served, a log is maintained. Log as in the details about what request came in and what was responded. So these details are maintained in the file. Now, let's say you want to aggregate all of this data almost in real time. Okay, and we are going to demonstrate to you, and you want to aggregate all of this data on HDFS. Okay, so that if somebody wants to query this data from HDFS, they can query, and you have the latest data available in HDFS. In case, let's say, one of these machines crash, you do not miss the data. Okay, so whatever data was there, it has been already copied to HDFS, and this is happening continuously. And that's what Flume does. Now, Flume agent can be different kinds. There can be different kind of agents. Some picking the data from a web server, some picking the data from other sensors or other files or uh, other services. Okay, we will show you what all services are there. All right. Now, so let me try to put it in technical words. Flume is a distributed, reliable, and available system for efficiently collecting aggregations and moving large data from many different sources to a centralized data store. Okay, so basically we install an agent, and this agent is installed on the individual machines or individual servers, from where the data is continuously being pumped to HDFS. Okay, now instead of HDFS, it could be something else as well, say S3 or some other source. Now this design of this agent is very interesting. Okay, design of the agent is such that is very modular, just like your USB cable. I will describe it. All right, you look at this diagram. Okay, so an agent is made up of a source and a channel and sink. It's a software component. Okay, agent is a software component in XML. In XML you can describe what kind of source an agent has, and what kind of channel it has, and what kind of sync it has. So every agent has three parts. Now, why do we need three parts? Because to make it so modular, let's think about it like a USB cable, okay, or any cable. On one side here, it's source, as in taking the data, say power, from this side, and the data is traveling from here, the electrons, and then going to the sink. Similarly, here in the software side, there is a source, there is a channel, and there is a sink. But the beauty about it is that there could be many kind of sources. Like here, if you have say it is goes into the, you may want other kind of cable which goes into the AC socket. So if you could just replace this with the AC socket, it would be wonderful. Similarly here, the sink might be some other phone. Okay, I'm just taking a analogy. Okay, so on a machine like a Flume agent, on a machine where Flume agent is running, you might want to pick the data from either say Nginx, Apache server, or say FTP logs. There could be many other things you want to absorb from every machine, and there could be different kind of syncs. Okay, similarly there could be different kind of channel, some in memory, some on disk, and some a combination of in memory or the disk. As in this channel, what does channel do? Channel basically holds data till the sync finishes writing, right? So if sync is slower, okay, sync performs like 60 MB per minute. In a minute, it writes once, say 60 MB data, and in source gathers 1 MB data per second. So every second source is getting say 1 MB, and sync is still performing its write, so it's taking 1 minute for it. So during that 1 minute, the data will be held in the channel. Okay, data will be held in the channel. So this 60 MB will be held in the channel. So basically the rate at which the data is being consumed and produced, sync is so the data is kept in the channel. Okay, so for example, the water tank we have in our houses are behave like more like a channel, because uh, while the motor pump runs once in a day, while we use the tap whole day. Okay, so the rate at which source produces data and sync consumes the data, that difference is what defines the what kind of channel are you going to have. Okay, so this architecture of Flume of the this component where sync could be different kinds, okay, makes it so modular that that a sync can send further the data to another source, and sync can send the data to multiple sources, and so on. Now, using these kind of topologies, you can create kind of a mesh network of Flume agents, so that you can take data from source to destination even in the worst case scenario. Okay, so Flume basically supports a large variety of sources, including tail, syslog, and log4j. What is tail? So if you have been to Unix earlier, if not, I'll describe you. So the tail command in Unix gives you last 10 lines. If you say tail very big file, it'll just give you last 10 lines. Now, what you want to do is you want to observe a file continuously. So what you do is tail minus f the file name. Tail minus f the file name. What would that do? That would keep on giving us the data, that would keep on printing the data to your screen as and when data is being appended to the file. So tail minus f acts like a monitor, and whenever you are running a web server, running a process, or anything, you generally do tail minus f the file name, so that you can continuously see what's being added to a file. Okay, rather than keep typing tail again and again, the tail minus f keeps on printing fresh data to your screen. Okay, so that's tail. And now, similarly, there is a service called syslog on the Unix machines, called whether Unix, Linux, or Mac. Everywhere there is a process called syslog. Syslog is a very interesting process. All the application in the Unix operating system, they give log to syslog process, and syslog can further write data into the file. Okay, so Flume can read from syslog because syslog is like a centralized logger on every Unix machines. Therefore, it makes logical sense to have syslog as your source of data. Next is log4j. If you are running a Java web service or a Java server, say JSP, J2E, or whatever, they generally give out the data using log4j. So you can have an agent pick up the data from log4j and push the data to HDFS. Okay, now Flume nodes could be arranged in arbitrary topologies as we showed you in the previous screen. And typically there is a node running on each source machine. Source machine is in the machines which are producing data. And when you have these tiers of aggregating Flume agents, the data flows through its way to HDFS. Okay, so you can basically, by arranging these things in topology, you can build various kinds of delivery reliability, whether best effort, okay, meaning does not tolerate any node failures, and end to end, which guarantees delivery to the node failures, okay, by parallel and sequence. So I'm going to give you a demo of a node agent. Okay, so we'll produce some data, and node as Flume agent will take the data and push it to the HDFS continuously. Okay, basically all I'm trying to say is we will create agents. We'll describe an agent. Agent is made up of three parts: source, sink, and channel. Okay, so a typical Flume configuration file looks like this. Okay, also note that there is a single configuration for the whole cluster. Okay, and for basically for all the agents, even if you have 1,000 agents, you create a single file and copy the same file to all the nodes. And while starting the Flume agent, we tell the agent that your name is this. So while the agent starts, it only picks up its configuration, only that part for it, the name we have given it to. Okay, so for example, here the agent name is A1, and A1 sources is R1, A1 sync are S1 and S2, A1's channel are C1. And what does it mean, R1, S1, and C1? So here, R1.type equals to netcat, R1.bind is localhost, and so on. So we are describing what is R1, right? And similarly, S1, we are describing here that what is S1 and S2, and then we will describe down what is a channel. Okay, I'll show you that here. You can see these are the channels. Okay, coming back to it again. So what are we trying to do? We are trying to set up Flume agent. Right now there is only one agent. There could be many agents, and all of their agents configuration will be looking like this only. We could also have things like this. We could have A2, A2, and A2. Okay, so everywhere when we run an agent, we give it a name. We tell it, hey, your name is A1, so it will pick up only its configuration. If we tell its name is A2, it'll pick up its own configuration and will start the process. Okay, right now here the source for A1 is netcat. What is netcat? Netcat basically create a server at a port, listens to it, and whosoever writes the data to it, it'll push that data to the file system. Okay, So we'll encounter netcat twice, once more while doing the stream processing. Okay, netcat is a very quick way to create a server. What is a server? Server listens on a port continuously for your data. Okay, so we are saying A1 dot sources. A1 reads data to a service which is going to run at this port. So this service is going to listen at this port, and whatever data we push it to, the agent will uh, pick that data, as in agent source will pick that data and then push it to the HDFS. You can see here we are saying write the data to HDFS. Okay, so that's how we are going to do it. Right now we are writing the same data at two locations, but we will, in the example, that is just for the discussion sake. So I'm going to show you the actual example rather than this. Okay, let me just go to the console. Okay, so let me okay, and also there is a, all right, okay, all right. So the details about Hadoop, this Flume agent, are also available in the data folder, data slash Flume. Okay, so the config file is also available here. The same one I have copied to my local folder. You can see here the conf. Okay, so in the conf folder, okay, this is my flume.properties, which contains my configuration for Flume. Now, are you able to see my screen? It shows here that A1 has got source as R1 and some sync here and so on. Okay, so here you can see that it's a HDFS cluster 1 sync. I've named it. R1 is my source, which is netcat, and channel is the memory. Okay, channel as in we are keeping the data in the memory. So we describe individual component and then we connect it here. Okay, also we give a reverse connection as in the source should know that who is its channel and sync should know who is its channel. So connecting R1 and S1. Okay, so that's how it is. All right, now coming back to the, so this is done. This is my flume.properties. Now I want to basically run my Flume agent. This is how I run my Flume agent. Let me describe the command bar. You can see that this slash doesn't mean anything. Okay, so here I'm saying Flume agent ng. Flume ng is a Flume main tool. Then I'm saying that run the agent, and here is my config directory, and specifically config file is here. Then the name is important, so you have to provide the name of this agent. What does it mean? That means that you could have definition or the configuration of all the agents in a single file and launch each individual agent with giving different names. If you are running the Flume agent on the A2 on different machine, you could run minus minus name A2. Okay, that makes our life really easy. Okay, so I will go up one directory and then execute this because I'm using conf slash flume.properties in the command. Okay, now let me open one more. Now it's listening. It says created a server socket at this. Okay, so right now it's waiting for my packets at this location. Also, let's have a look at what exactly it's going to do. Okay, what was the location? I forgot to check. Let's just first check. Let me open one more terminal. Let me open one more terminal. Okay, this is another one, and Okay, so so on the second one, we are running our ANSI. So you can see that it has created the same, created the agent. It's waiting for my data. Even if I don't provide the data, it will keep waiting. Okay. And let me open one more thing. Let's open Hue. Okay. So right now, whatever we are doing, it's very important because this is the way generally we establish the whole input mechanism in an organization, specifically while picking up the logs. Okay, logs from the web server. So coming back to it, so what was the location? I forgot to take. So let me just go to Flume folder and conf/Flume properties. Okay, so you can see here it says in this folder Flume web data. Okay, Flume web data here. Oh, is it? The other one? Uh, Flume dash web data. Yeah, this is the one. Okay, let me clean this. All right. So you can see that right now it has created. Okay, these are from the previous session. Let me just delete all of this data. Okay, let me just delete it, move it to trash, move it to trash. Okay, let me delete more of these. Wow, looks like we saved a lot of data. All right, I think a better idea would be to just hadoop fs minus rm r, and then I would say Flume web data. Okay, so does it give error here? Never mind. So let's just try to talk to this agent. Okay, this agent is running on localhost at this port, right? So let's talk to this agent. And how do we talk to this agent? Either we could use telnet or we could use NC. So we are saying using NC, we are saying that connect to the local host at the port, whatever that service is running. Now we are talking to that. Okay, so whatever we write here will be taken by the Flume agent and then will be written by it to the disk. So I'm just writing something here. Okay, so I can, using NC, I can talk to any service, whether email server, whether web server, or any service. So right now I'm talking to this temporary service created by my Flume agent. Okay. So now you will see that, let me refresh. Okay. Yeah. So this is my newer data, which is just created. And what does it have? It has in the something called bytes writable format, and it contains the same data what I'm writing right now. Okay, so if you don't believe me, I can actually write somebody's name, say Prabhund. Okay, Prabhu, Rajiv, Vishnu, and Suraj. Okay, Satyan, Ashmit. Let's just go and check if the data is there. Okay, also let me just post your questions there. Okay, let's just see if it is going there or not. All right, now let's refresh here. Okay, so which one is newest? Newest is at the bottom. All right, you can see Prabhu, Vishnu, Suraj, Satya. So it's in a binary format. Okay, so whatever we have typed there, it has come here. So it's continuously waiting for data. There could be many more writers which can talk to this service. okay, continuously. Say you if you are also logged in on console, you can also connect to this. Okay, Vajinder is saying this. Okay, good. You can also connect to it and write your data right away in the same way the way I'm writing and see localhost in that. So yes. All right. So this is how the data gets transmitted to HDFS in almost real time. Sounds great. And as a matter of fact, we did at Amazon, we did have different kind of tools. Okay. Before Flume itself, we had built some kind of tools, and that was very, very useful. Say, for example, we were doing a real-time analysis of errors that are occurring on the website. So a lot of error correction happens by the system itself. So let's say this is very, very important. So you might want to know this part. So what was happening is that there is one web server, second web server, third web server. Okay. And at Amazon, we used to launch many more, the many more changes every day. Every team was responsible for a small part of the website. Somebody is responsible for Prime, somebody is responsible for the headers, somebody footer, somebody on the main page, and so on. There were many more teams. So everybody is pushing their changes into the production, and every change was recorded in the repository label. Now on the server, what we used to do is we used to monitor what is going on, okay, by basically pulling data from all the machines continuously, okay, and then here we used to run the analysis continuously. So basically, logs are being pulled from all of these machines, okay. So the logs are being pulled from all these machines continuously, and there were say around 100 servers, okay, 100 servers serving the request, and from all the 100 servers we were pulling the data, and continuously we were analyzing the same error message. So we were grouping data by error message. Okay, so if a certain error message has bigger count, if it has some biggest count, we would just look at that one and figure out the stack trace, and whatever stack trace it's giving, we find out which repository it's coming from, and then we revert that to the previous version. And this used to happen very, very in a very automatic fashion. That means that the newer version of a particular code is giving error. Let's revert to the previous code, and that's how. And immediately open the ticket against a team who against the person who has committed into that branch. So that way, lot of error handling was happening in the real time. Did it make sense to you what I described to you? A lot of error correction and error handling was happening in real time. Okay, so using Flume, you can do basically pull the data on the server. You can run your own say MapReduce tasks to continuously group the data, and then after you realize that a certain error message is occurring at a very much higher frequencies, then you basically start taking action, as in revert that particular code in the production, or inform the right team by cutting a ticket against them. Cutting a ticket against as in log a ticket against a team. Ticket as in log a request or send them email saying that your product is breaking the production. Okay, and then the whole team gets into action and they keep on working. That's how we used to do at Amazon. All right, so we were able to push the data at such a high frequency. Also, there is a command called yes. Okay, so this yes command, just keep on printing Y. If I pipe this data to NC localhost at 4444, now you'll see the magic. This is what created, now you can see, is pushing data like a million Ys in a second. You can see so many files have been created already. I see. It shows that 2 pages have been created. See that? 4 pages have been created. 5 pages have been created. Okay. And then now let's see. 7 pages have been created. So 7 pages as in these many files. Every page will have so many files. Okay. So as we refresh, it'll keep on doing the work. 12 pages. Interesting. So it's pushing data at a very fast pace into HDFS. So that was a quick demo of the Flume. You can also give it a shot. Okay.